Hello, this video is on logarithms, as shown here in the syllabus. You should be familiar with the concept of an operation and its inverse. For example, the inverse of squaring is square rooting. If 5 squared is equal to 25, then the square root of 25 is equal to 5. Exponents, or powers, and logarithms are inverses of each other. If 10 raised to the power of 2 is equal to 100, then the logarithm in base 10 of 100 is equal to 2. This can be demonstrated on the calculator. 10 to the power of 2 is equal to 100, and the logarithm in base 10 of 100 is equal to 2. Notice that the abbreviation of the word logarithm is simply log. Similarly, if 2 raised to the power of 3 is equal to 8, then the logarithm in base 2 of 8 is equal to 3. In general, if base a with an exponent of b is equal to c, then the logarithm in base a of c is equal to b. So the logarithm in base a of c is the power that the base a must be raised in order to obtain c. For example, the logarithm in base 10 of 1000 is the power that 10 must be raised in order to obtain 1000. And that value is 3. When the base of the logarithm is 10, we tend not to write it. We simply write log c. A logarithm with a base 10 is referred to as a common logarithm. And there is a special button on the calculator for base 10 logarithms. To calculate, say, log of 1000, we simply press the log button and then press 1000, giving the value 3. When the base of the logarithm is e, we write ln instead of log. A logarithm with a base e is referred to as a natural logarithm. There is a special button on the calculator for natural logarithms. For example, the natural logarithm of 7.389 is approximately equal to 2, which is the power that you must raise e, so 1.999992408, in order to get a value of 7.389. A logarithmic function has the general form log with a base a of x. And since exponents and logarithms are inverses of each other, the graph of a logarithmic function is the reflection of the graph of an exponential function in the line y equals x, as shown in the diagram. In the example, the exponential function 2 to the power of x is shown in blue, and the logarithmic function log with a base 2 of x is shown in red. In part A of this question, you're asked to find the magnitude of an earthquake which releases the given amount of energy. So if we use the given formula and substitute in the value of E. Enter in the value of the expression into the calculator, pressing 1 for a run matrix, then the fraction button, entering 2/3, then pressing the log button for a log in base 10, opening a bracket, pressing the fraction button again, entering the value of e as a numerator, 5.1 times 10 to the power of 10, and then for the denominator, 10 to the power of 4.8. Pressing the right cursor twice to come back up, and then closing the bracket. Pressing execute to get the required value. So the magnitude of the earthquake is 3.94 to 3 significant figures. In part B, we're asked to find how much energy is released by an earthquake of a magnitude 4.3. If again, we start by using the given formula and substitute in the value of m to form an equation. We can use Solver on the calculator to solve the equation. From the main menu, select Equation, and then press F3 for Solver. Typing in the equation, so pressing 4.3 and then Shift to access equals, followed by the fraction button, and entering 2/3, and then pressing the log button, opening a bracket, and using the x variable to represent e, putting it in a fraction, and in the denominator, putting 10 to the power of 4.8. Bringing the cursor up, closing the bracket, and pressing execute to enter the equation. Just note that the number next to x is not the solution to the equation, as we haven't pressed solve yet. Pressing F6 to solve the equation gives the value of x, or e in our case, as shown. So the amount of energy released is 1.78 times 10 to the power of 11 joules, correct to 3 significant figures. In part A of this question, we're asked to find the height of the plant after 4 weeks. Starting by using the given function and substituting in the given value of t. So that's 0.25 plus pressing the ln button for a natural logarithm, opening a bracket for the calculation, and put in 0.3 times 4, closing the bracket, pressing execute to get the required value. So the height of the plant after 4 weeks is 0.432 meters, correct to 3 significant figures. Alternatively, we can use graph on the calculator to solve the problem. From the main menu, select graph. Type in the equation into y1, that's 0.25 plus pressing the ln button for a natural logarithm, and then 0.3 pressing the x variable button. Pressing execute to enter the equation, and before pressing draw, we can press Shift F3 to set a desired window. For mainly positive x values, we can set x min at say -3, and x max at 25 with a scale of 5. And then for positive y values, or mainly positive y values, we can set y min -1, y max of 3 with a scale of 0.5. Pressing execute to enter these values, and then F6 to draw the graph. The height of the plant is represented by y, so we need to perform a y calculation. On the calculator, press F5, Gsolve, F6 to get to the second page of tabs, and then F1 for a Y calculation. Entering the value of X, so 4 weeks, X is equal to 4, pressing execute to enter the value. Given a Y value, or the height in other words, of 0.432, as before. In part B of the question, we're asked to find the number of weeks it takes for the plant to reach a height of 2 meters. So again, starting with the given function and substituting in the value of h, which is 2, to form an equation. We can either use solver on the calculator to solve the equation. So from the menu, select equation, press F3 for solver, type in the equation. So 2, shift to get down to the equals, 0.25 plus pressing the LN button for a natural logarithm, and then 0.3, and using x variable to represent t. Pressing execute to enter the equation, and F6 to solve the equation. Given the value shown. So that's 19.2 weeks for the plant to reach a height of 2 meters. Or, alternatively, we can use graph on the calculator. So returning to the main menu and selecting graph, pressing F6 to draw the graph again. Since we want to find time, which is represented by x in the equation, this is an x calculation. Pressing F5, G-solve, F6 to get to the second page, and then F2 for an x calculation. Entering the given value of y, which is a height of 2 meters, pressing execute, gives t equals 19.2, given the same value of t as before. It takes 19.2 weeks for the plant to reach a height of 2 meters.